audible?
Yes, sir.
Okay, let me just see if it is streaming or not. Audible?
Yes, sir.
Okay. So it is recording and streaming. So let us begin. Anytime you face an audio or any video issue, just tell me. So let me share my screen. Okay, so today what we'll do is, hope it is, yeah. So what we'll do is, we'll be completing after completing functions, derivatives and integration. We have reached to the part where we have also seen how to calculate volumes of solids by rotation using cylindrical, using disk methods and washers method, and different methods where you actually segment the solid into so infinitesimal volumes and then sum them up. So each infinitesimal volume we saw could be written as a some integral, as for example we had seen if we rotated a solid across the x-axis and the curve across the x-axis in 3D. So if this is fx, and then we had said that the differential area that the solid will have would be 2 pi or pi f of x square times dx. So this is your differential volume that you will have, and then you can integrate both sides to get the volume. I hope you remember this, right? So this is
Yes, sir.
correct. So let's begin with today's session. So we'll just see another method in which see here what we were taking disks, right? These are all disks. Agreed? These are all disks that we were using to calculate the it's a circle with a little amount of infinitesimal amount of width. So we were using this to calculate our infinitesimal volume, right? And then we were integrating or summing those volumes up to get the entire area. In the cylindrical method, what we'll be doing, it's useful when, see, in the cylindrical method also you can use the disk method, but often it can be useful because the integral it forms may be a easier one. For example, you have a square over here. You will not have a square in this case. You will have something else. Let's see what. So I have written it down over here. So let's, for example, write it separately and see how does it look. So sorry for the scribbling here. Okay. So for this cylindrical method, say you have a curve like this, right? Or any curve, for example this. Agreed? So what we'll do is, and it was say rotated about the y-axis. So y-axis formed the axis of rotation. So what would you have? You would have a figure something like this. Agreed? If you
Yes, sir.
yeah. So next what we would do, and you wanted to find this volume. So what you can do, you can break this up into small disks. This is one possibility, right? So you can have this f of y if you could, right? Or if you could, yeah, and then integrate from y1, y0 to y1. This is your disk method. Y1 f of y squared pi times this into dy, right? We could do this. This is your volume, correct, right? You could also use this is what we did the last time, so we could also do something like this. So you see a volcanic peak, sort of a volume here. So you could also, for example, this is your curve. So at every point you agree that it will form a cylinder like this. Say at x, this is your f of x, right?
Yes, sir.
Correct. So if you rotate it, you rotate just this point, you get two circles, a base and the top of a cylinder, right? You get two surface of the cylinder, and when you form the cylinder with a height of fx and a radius of the base x, so what do you get? You know the surface of area of the cylinder is, or the d or the s of the cylinder as a function of x is 2 pi x f of x, which is nothing but 2 pi r h, right? Because 2 pi r is the circumference of the base, and you multiply that with the height, so you get the surface area of the cylinder. You agree with that? This is your surface area of the cylinder.
Yes, sir.
Very good. So what we'll do in this case, we will, all this while we were moving the disk, right? So we have an area. So you see the area is a curved surface now. Now if I increase this infinitesimally, so we will assume that since the function is continuous, f of x plus dx is almost equal to f of x, right? So your volume that you will be having would be something like this. So let's draw it in separately. So your infinitesimal volume would be something like this. You can also find the volumes by using the area of the circle and get the same answer, but let's see. This will be your volume. Agreed? And
Yes, sir.
so we can do it in two ways. So what is the volume? You see the surface area s of x, and you are having a dx movement here, right? Dx. This is directly, you can see, is the volume that you will have, the differential volume you will be having. Agreed? So we have seen this. So if you have a surface area and you multiply the length with the cross sectional area, you get the volume of the solid, right? So in this solid you will get a dx s times dx. So if you are not able to visualize, you can also do something like this. So what is the area, or which is also equal to pi times, this is your r1 and this is your r2, right? Or r plus, so if this is x plus dx. Let's just write this down, so in case you're not convinced with this. If this is dx, so this is r2 is x plus dx, r1 is equal to x. So what would be the volume of the solid that I have shaded? Could you tell me the volume? Pi r square
R2 square minus R1 square.
Correct. Or capital R is the r2 square minus small r square into the height, right?
Height. Yes, sir.
So height is f of x in our case, and we have assumed f of x is close to fx since it is continuous function. There is nothing to prove in that. So you will get something like x plus dx square minus you will have x squared into fx. So what will you be having here? You will be having x squared will get cancelled. You will be having dx whole square plus 2 pi x dx. What am I writing? 2 pi 2x dx times fx. So dx square is much smaller than 2x or dx, right? So it's an infinitesimal volume, and you're squaring that, it becomes almost like of the orders of magnitude smaller than the volume that of this quantity, right? Dx is orders of magnitudes lesser than dx. So you agree with the approximation that we can set this to 0 just like we do in Taylor series?
Yes, sir.
So this is the volume approximately becomes to be 2 pi x fx dx. So you see the simple figure gave the right answer. So this is your surface area at x times dx is your differential volume, right? We are using the same property. So now let's do some interesting questions. We have a couple of questions that were in your assignment as well, so we'll do 1 and 2. These were the tougher ones, so it's not trivial to do these. So let's try and do this and try to apply the methods that the cylindrical method to solve these questions. Let's see. So how will we do this? So you're saying you have two equations, y square is equal to 4x and y is equal to x. So let's draw this figure. So from between y and you have a line, two lines, x is equal to 4 and y is equal to 4. So one of the curve is this. This is y equal to x. What is y? Y square equal to 4x. That's a parabola, right? Rightward opening parabola. And we only want the top of it. We don't want what is happening below, because we want always y is greater than 0 in case of when you are trying to form volumes of rotation, right? So this is your y square equal to 4x. So no, I just keep this y is equal to 4, x is equal to 4, and then this is y square is equal to 4x. So you are saying, see, y equal to 0 and x is equal to 0, or the x axis and the y axis are straightforward questions, right? So you can just use the formula and get the answer. Do you agree to that we have derived now? There is nothing to worry about. But
Yes, sir.
when you are rotating about a different axis, so you see the 4, 4 is the point where these two curves meet, right? So you see, put the values of 4 square is equal to 4 into 4 and 4 is equal to 4. These two curves meet at 4, 4 and 0, 0. You agree, right? So you are told what is the volume formed when this surface is rotated across this axis. This x is equal to 4 and y is equal to 4. So what do you think we should do? Do you have an idea? See, when you are rotating about the x-axis, this is centered at the origin. Here, when you are rotating about this, a farther point is centered at the origin, centered at this 4, 4. You see the difference between these two, right? It's
Yes, sir.
not exactly the same. So what should we do? Any idea? I think we had done a similar thing last time. So we would be recentering the curves. Would that work? If I make this the origin, this trick you can use always. If I make this the origin, I can use my normal equations to solve the question. Do you agree? So let's see how will I do it. So you can do any other method, but it will be a bit lengthy, but let's try shifting the origin. So for example, y is equal to x will remain the same. You agree? Because y minus 4 is equal to x minus 4. It remains the same, right? some x prime, or let's write tilde, is equal to this for the line. You agree?
Yes, sir.
With respect to O dash, you will have the same figure, same curve. So, and the next one, what will it be? Can you help me? Y square is equal to 4x. How will I do? What will I do? I'll complete the squares, right? So I'll make it y minus 4
Y minus 4 whole square is equals to 4.
Or
X
I'm just,
minus
what I'm doing is, yeah, you're right. So I'm just removing, you will have minus 8y here, right? When you expand this.
Yes, sir.
So I'm just removing that. And I'm also removing 16, right? You'll have 16 also.
Yes, sir.
So these two are equivalent statements now. Is equal
Yes,
to
sir.
is equal to 4x minus 4
Minus 4
plus 16.
plus 16. Yes, sir.
So this is equal to 4x and this is equal to y square. We all agree to that, right? Now what I do, y minus 4, I'll bring y 16 this side. So what will you have? 8 I'll take common, so you'll have y minus 4 again, right? Is equal to 4 times x minus 4. Agreed?
Yes, sir.
So now what will we have? Now the equation becomes interesting. So this I can recenter as x tilde is equal to y square plus 8y by 4. Agreed?
Yes, sir.
So this I'm writing as y tilde, this I'm writing as x tilde. So next, what you have done, we have recentered this curve. Now you see, now your rotation becomes exactly like your x and y axis. So it's simpler to rotate about y equal to 4. Do you agree? Because the equation in terms of x is a simpler equation. You don't need to rotate or something like that. So y equal to 4 is you don't need to take square roots and all. That's what I'm saying. You agree to that, right? So so you have x tilde is equal to y tilde, and x tilde is equal to y tilde square plus 8 y tilde plus by 4. These are the two equations that with respect to O dash. So this is clear, I guess. So now I'm rotating about y equal to 4. So what will happen? Which are the volumes that you will be getting? You will be getting spheres like, or cylinders like this. Or let me see. So you will be having like this. Just a minute. Yeah. So this would be your cylinders that you'll be using.
Yes, sir.
And you will be also having an internal cylinder like this. Which you would be subtracting in some way, right? And that's the idea that you are going to do. And you would be generating the solid that you would be having. So what is the step that we need to do? Just like the washer method, what will we do? We will do, the volume would be, can you tell me? 2 pi. In our case, we'll be integrating over y, right? 2 pi y, f of y, f1 of y minus f2 of y dy. Do you agree?
Yes, sir.
So this is, or you can write this here, 2 pi r h, or hr, whatever you want to say. Let's write y first, then it will be rh, right?
Yes, sir.
Between minus 4 and, so with respect to 0, is this minus 4?
Minus 4 to 0.
Yeah, with respect to O prime. Very good. Minus 4 to 0, and you will put a negative sign. Do you agree? Because this volume is negative.
Negative. Yes, sir.
Towards negative axis. It was a negative quadrant. Towards negative quadrant. Or you can say y tilde is less than 0. as y tilde is less than 0, so the integral will be a negative quantity, so you'll put a negative like this. Or you can write exactly like minus 4, 0 to minus 4, 2 pi. Which one is larger? Your y equal to x is larger, or yeah. In our case, let's see. So if we take this, it's more negative, and this is less negative, correct? Or you could just, this turns out to be x minus, so y tilde. So I'm just writing in terms of y tilde, just remember that. Y tilde minus y squared plus 8y tilde by 4. Y times gy. I don't think we need to put a negative sign. Let's see. Let's, for the time being, put a mod outside and then we'll see. Okay. I'll explain why it is not required, because y is already negative here. Y is also negative and your f of y is also negative, so it's okay. So let's put a mod, keep the mod outside, and let's solve the integral in terms of y, right? So minus 4 to 0. So you can get 2 pi y by 4, and you'll be having 4y minus 8y minus 4y tilde minus y square, right? Y tilde square dy. Just follow solving the integral. Okay. Next, you will have 2 pi by 2. I'll just keep out, and I'll integrate minus 4. Both are minus. I can just flip the integral as we have been doing all the while. So 4y tilde square plus y tilde cube dy. You agree?
Yes, sir.
So you will be having something like 4y tilde cube by 3 plus y to the power 4 by 4. Just put y here. What will you be getting? So you'll get 4 times 4 minus 4 cube at y equal to minus 4 cube, or I'll just remove the minus and put a minus outside, by 3 plus your y to the power 4 to the power 4. Somewhere 3 was there, right? So I don't see the 3, 4. So you will have, this is the y to the power 4 by 4, right? So I'm just writing it in the reverse order, that's the problem. So 4 times minus 4 to the power 3 by 3. Did I put the limits correctly? Just a second. From 0 to 4, correct. And you'll be having 4 to the power 4 by 4. Correct. So you'll be having pi times second, I'll just 4 times this, so minus 4 minus 4y minus 8, so this is correct. This is 12. Wow, 4 to the power 4 everywhere. So what are we having? So we'll have 12. So this is 12, it is 4, and this is 3. Right? Minus of 4 to the power 4. Hope this is correct.
Sir, minus 4 to the power 5 plus 3 4 to the power 4 will come, no?
No, it's correct only, na? 4 minus 4 into 4 to the power 4 plus 3 into 4 to the power 4.
Okay, sir. Correct.
Yeah, so this is minus pi 4 to the power 4 by 24, or 12 into 2, which is pi 4 will get, you can cancel 1 4, so it gets 4 cube by 6, or 64 by 6, or 32 minus 32 pi by 3, right?
Yes, sir. Correct.
Yeah, so what we did is, so there was a need for, so you'll put a mod throughout. So mod I is, I'll tell you why a negative sign was required. Mod I is equal to 32 pi by 3. If this is your volume. So you see what we were doing is pi of 1. So this is more negative, right? So y tilde, for example, is, or rather y tilde would be less than 8. Where's the other equation? 8 y tilde plus y tilde squared by 4. Just put any value, just see minus, for example, minus 2, right? Minus 2, at minus 2 it will be minus 16 plus 4 by 4, right? Minus 12 minus 3. So this is y tilde, whatever, I don't know, like minus 4, right? Minus 2 minus 16 plus 4 by 4. So you get minus 3. So minus 3 is lesser than, so it's more negative. The mod of this is, you agree? And
Yes,
this,
sir.
and this is
Understood.
less than 0. So what will you be getting? You will be getting this, right? It's
Greater than.
yeah.
Yes, sir.
So your y tilde, am I writing it? Yeah. At y equal to 2, for example, y equal to minus 2, you're getting, these are values of x, right? So that's the thing. F of x tilde is what you're trying to calculate. So at what point are we saying? We are moving upwards and we are trying to find this corresponding value. So at a point of, so that's why it's not coming correctly. So y is equal to 2 means this line, right? This line. So in this case, you see clearly this is towards we were seeing the other axis. So this is the axis, right? Y is equal to minus 2. So you, in this, if you see this axis, your y tilde is greater than the parabola. You agree?
Yes, sir.
So if you subtract, so if this is greater, so we have subtracted this minus 8y plus y square by 4. This is greater than 0. Agreed?
Yes, sir.
This is greater than 0, and here you needed to, and this is less than 0. So you needed to put a minus y. Right?
Okay.
This is less than 0.
Yes.
Y is less than 0, right? Minus 4 to 0. And this is greater than 0. So you are having a negative volume, just put a negative sign explicitly outside. So this was the first question that we did. The second part says that what would happen if you rotate about x is equal to 4. So again we can work with the same origin, right? So these are the two equations that we have. Copied, and we'll just question 2. This is question 2. So in this case, all we need to do is integrate 2 pi x f of x, right? F of x minus f1 of x minus f2 of x. That will do it for us. Minus 4 to 0.
Yes, sir.
So all you need to do is change the subject. right? And we have, because we have already made the origin accordingly. So change the subject, what will you get? So you'll get 4x tilde is equal to y square plus 8y tilde. If you add 16 on both sides, you'll be getting 4x tilde plus 4. This is the original equation that you're getting, right? Y tilde plus 4 squared. This is your original equation. Y tilde plus 4 is nothing but y. That is y square equal to 4x. Are you seeing the relation?
Yes, sir.
Good. I'll just paste this thing much later. This will be useful, I think. Just give me a moment. Cut it. Yeah. And I'll also paste this as well. Okay, so let's do this question now. I think we missed some parts of it or what? Did we copy it? Yeah. Okay, we'll erase this part. Sorry for the delay here. I just copied it, so that's why. Okay, so let's see. So we left here. So if you see, this is nothing but this equation, right? Y is equal to 4x. But we'll not be using that for a reason. So you see, what will you be left with? So y is 2 square root of x tilde plus 4 minus 4, right? This is your y tilde?
Yes, sir.
Right. This is your y tilde. This is, you have also plus minus somewhere here. So you see, this is your negative, so this is the, and you also have the second part of it, which is y tilde is equal to x tilde. So in this equation, you would be having these two parts. So you have again made this the origin, and you're trying to rotate it about the x is equal to 4 line. We have already rotated about the y equal to 4 line. Now we are trying to rotate it about the x is equal to 4 line. Right? So what would we do in this case? So in this case, is this equivalent to rotating this graph about the y-axis? So you see, the both this equation that you will be having, this equation is nothing but 4 square is y square is equal to 4x, that you already had here, right? So your x values are ranging from -4 to 4. In this case, let's see the values of y, right? So your values of y, x is between -4 to 0. So if it is -4, this becomes -4, y becomes -4, and if it is 0, this becomes 0, right? Your x tilde value, this is matching, right? If you take the positive side,
Yes,
so it's not So the negative root is not the solution. Negative root is towards this side, right? This is your negative root. This is your minus 2 root over of x tilde plus 4, right? This is your negative part. And this is the positive part. You agree?
Yes, sir.
So we only need the positive part of this equation. So now you tell me what would be the area. Again, you're rotating about the x is equal to 4 axis. So what? How will your cylinders will look something like this?
Yes, sir.
Yeah. So tell me the integral. What will be the integral? So dv. What will be dv? 2 pi. Whichever you are having. Let us take the outer one first. So you will have 2 x tilde plus 4, which is greater than minus 4
minus x tilde
into x tilde, right?
dx.
Minus 4 to 0, right? So you see, this makes the equations or the question simpler to solve. So this is going to give me the integral as 2 pi integral of minus 4 to, so why is it? So you see this curve is above the y equal to x line, so that's why I have subtracted the lower quantity. So you to have a positive quantity, and x is greater than 0. Again, I think we'll be needing a negative sign, right? This is greater than 0, right? This is greater than 0, and this is less than 0. So again, we'll solve it with the modulus, and then we'll be seeing if it is actually matching the negative sign, and will be good then. So x tilde, that are the two integrals, x tilde plus 4 dx, right? And minus to 0 4 times can we make it simpler? So okay, 4 times x tilde minus 4 to 0 dx tilde minus x tilde square dx minus 4 to 0. Right? Is this expansion correct? I guess it is, right? So this is the second one, and this is the third one. Correct. So that second integral will become minus 4x squared by 2, or you will get 2x squared, and at x is equal to minus 4. Agreed?
Yes, sir.
And you'll be having this integral as, again I'll flip the sign and make it positive, minus 4 to 0, 0 to minus 4. You'll be having x cubed by 3, so minus 4 x cubed by 3, right?
By 3. Yes, sir.
So these two integrals we have solved mentally. The third one is this. So 2 pi, you remember, is outside here still. So x is equal to 4 would be 1632, right? This is 32. Right? I'll just not erase this. Let's have this. This is equal to 32. X square is 16, 4 square is 16 into 232. So the integral of minus 4 to 0 to x tilde x plus 4 dx tilde. So how do you think we'll solve this? What should we do?
Sir, we can substitute x tilde plus 4 is equals to t square.
Okay.
Then we'll write x tilde is equals to t square minus 4 and into t square.
Very good. We can do that, or we can do integration by parts as well, right? Integration by parts. So which one will you integrate and which one will you differentiate? You can integrate this and differentiate this. Right? Exactly what.
No, sir, we will integrate x tilde and differentiate under root x.
If you differentiate this, so what will happen? You will get a denominator of this. So you'll get 1 by root over of x tilde plus 4. So if you take t square is equal to 4x plus t, in that case you will be having a proper equation. That's the correct thing. But I think there also it will not work, right? So you will have a root over coming up here, so that will not work. This is one of the integral exercise. So you are saying t square is equal to x tilde plus 4, right? So your x tilde will become t square minus 4 again.
T square minus 4.
Oh, you are saying then it will become an easier integral to do because you will have t outside. You can do a 2t dt, right?
Yes, sir.
Dx is, but dx will again come 2t dt. You will have a t square again outside. So you can't leave out integration by parts here. You have to do integration by parts. You understood the problem? If you let's do it.
Sir.
T square is equal to x tilde plus 4. If you do, so you'll have 2t dt is equal to a dx, right? So you'll be left with 2 times your x tilde is root over of t square minus 4 into t into 2t dt. So you will have a t square root over of t square minus 4 again, right? This will be a new integral, agreed?
Sir, same problem.
Yeah. So what will you do now? There's an easy equation. See this one if you integrate, and this one if you differentiate, you will be removing this. See why am I saying this? So integrate this equation. So you will be left with x tilde plus 4 to the power 3. Yeah, it's okay. 3 by 2 into 2 by 3, right? Right? Into x tilde.
Yes, sir.
And the second part, if you differentiate this, it goes to 1.
Yes, sir.
And you will be having 2 by 3 into
2 by 3
to
x tilde plus 4.
X tilde plus 4 to the power of 5
3
by 2.
2.
Yeah, again 2 times you will integrate.
3 by 2.
3 by 2.
Yes, sir.
3 by 2, 2 by 5, right?
Yes, sir.
This will be the integral. So now you see this goes to 0 always, right? At x is equal to 0 and minus 4, both it is 0. Right? One of the other factors cancel out. And this one remains only at x is equal to 0. So you will get something like minus. You will be getting something like minus of 2 to the power 5 is 4 is 2 and 2 to the power 5 is 32. 64, 128 by 15, right? Right? So these are the integrals that you need to do. If you put everything together, I think the answer that you'll be getting, so I1 plus I2, as I had worked out, let me just see once what was the answer. So I'll just not waste time behind doing fractions and all. So let's see, just a second. So this is your, so you'll get 64 pi by 5. So the same answer we are getting, right? 8 into 32 minus 32 by 64 by 3, right?
Yes, sir.
So we got the same thing. I think we have a 2 into 2 into 4 is 4, just a second then. Oh, you have another 2, right? Outside this 2. So I1, I2, I3 is 8 into 32. So if you did not spot this calculation error. So 8 into 32 plus 32 minus 64 by 3 into 2 pi. And you need to take a mod of this, as we discussed before, will have a negative sign, right? So this will turn out to be 64 pi by 15 or 5, right? 5. That's what we did. Agreed?
Yes, sir.
So I1, I2, I3 I integrated, and I said that we needed to multiply a negative. You understood why, right? It's because your x is less than 0 and your
X is negative and that is positive.
yes. So we multiplied that. So Mr. Pandey, what we did is, for this question 1 and 2 that were in the exercise, we saw how to translate the axes into the x-axis and the y-axis to a comfortable position, like just like the one that we did last week. We had translated the x and the y axis to a useful position so that we can use the cylindrical method or disk method, whichever we are comfortable with, right? That's what we had been doing. So I hope this question is clear, right? We can go to the next part, which is much simpler. So next one is our line integrals. So these are quite simple problems, but we'll be seeing how to solve them. So I'll just copy these two and then we'll be see. Just the integrals are what you need to do. Rest is, let's just paste it over here. Before we go on to doing these questions, let's see what line integrals are or distance between lines are. So you see, if you have a curve like this, right, that is given in sum, y is sum of f of x, right? What is the length of this curve approximated? So you say this is your x comma y and you have a ds, right? So you try to integrate the surface. So if you get integral of ds, you will get the length of the curve. You agree? Over the surface C, over the curve C. You agree or not? So this is what I'm writing as ds, this infinitesimal length on the curve. So can you tell me what is this infinitesimal length going to be? If you have this as dx, your d for a continuous function, you will have an infinitesimal dy. You agree? Am I audible?
The under root d square plus dy square.
Am I not audible? I think I can't hear any one of you. Yeah, now I can hear. Yeah. So I'm saying that ds.
Sir, under root dx square plus dy square.
Correct. Pythagoras theorem, dx. No, I'm saying that is okay. That is simple. I'm saying if your function is continuous, do you agree dy will be infinitesimal if dx is infinitesimal? Otherwise, your integral will not exist, right? So your dy dx is constant, right? So your dy tends to 0 when is equal to 0. Limit dx tends to 0, right? Agreed? Because this is c dx. You agree?
Yes, sir.
That's why we can sort of, for an infinitesimal change in x, we can at least take an infinitesimal change in y for continuous functions. For non-continuous functions where there's a jump, we cannot take that, right? Because your y can have any jump, right? For example, 1 by x, we cannot integrate at x is equal to 0. You agree, right? You will have an infinitesimal line. You will have an infinite distance on the curve. I hope I have been able to. Yes. So your for a continuous function, this will be for continuous function. So if a line integral equal to length of the, so line integrals are not exactly the same. You can have line integrals for more complicated stuff, but this is also a line integral of a function 1, for example. So where you can also have other variables coming into the line integral. So yes, so you can say that it is a length of a curve, correct? No, the concepts are similar, but you'll be using the same concepts that we'll be using. This is a line integral, d of x. This is all line integral. But you can use line integrals for different purposes in multivariate calculus and any other places, right? So this is a line integral. So you'll be finding the length of a curve in this way. So you see, so if you take dx square plus dy square over the curve C, this is your length is equal to, if you take dx common, so we have seen that using limits that dx and dy we can always treat them as fractions, unlike second order derivatives. First order derivatives are linear functions. so we can treat them like fractions. So this is what you will be getting, right? So you'll be having your derivative of the function times dx over the curve C, right? I hope this is clear. So let's solve these questions and see what we are going to get. So for example, the third one. So what are the components that we need? Your length is given by integral of 1 to 32 1 plus dy dx squared dx, right? What is dy dx here?
So 5 by 12 into 6 by 5.
What is that? 5 by
1
12
by 5.
half, right? X to the power 1 by
x 1 by 5.
4. It is also half, right?
Minus 1 by 2 x to the power minus 1 by 5.
This calculation is right, right? 6 by 5, yeah, it get cancelled and so on. So you'll be having half into x to the power 1 by 5 minus x to the power minus 1 by 5. So let's integrate this. This is the square of this will become 1 by 4 dy dx squared is 1 by 4 x to the power of 2 by 5 minus x to the power 2 by 5, or you can just write this, leave this, minus 2 by 5 plus 2, right? What am I writing? This is correct, right? So your dy dx, your line integral becomes half 1 to 32 1 minus 1 plus x to the power 2 by 5 plus x to the power minus 2 by 5 minus 2, right? So what will it give me? Half 1 to 32 2 by 5 minus x to the power minus 2 by 5 minus 1 dx, right? 2 by 5 minus 2 by 5 minus 2. I just squared the term that we got, right? Agreed? Now what will we do? How will we integrate this function? Any idea? So you see, x to the power 4 by 5 plus x to the power 2 by 5 plus 1, right? And x to the power 1 by 5. Is it? Can you so you see, this is your, these are the two equations are correct, right? This equation is correct. Can you unmute? No, it is correct only. So what we'll do is we'll be dividing this by x to the power of minus 2 by 5 if I take the LCM, right? So I will, this is 1 by x to the power 2 by 5. So this will give me what? This will give me x to the power 2 by 5 plus 1 plus this, and you'll be getting x to the power minus 1 by 5. Agreed? You'll have this under root. So you'll be having, so I think if I take x to the power 2 by 5 as t, so I'm seeing some calculations. I think this is correct only. We have squared this. No, we have done that. So this is your, yeah. So you have half, right? So correct. So am I? Are you only able to see my? Yes, I think I. Oh yeah. Okay. I think I'm audible. Okay, it's good. So this is your dy dx, right? So 1 plus this, sorry, x to the power of 2 by 5 plus x to the power minus 2 by 5 minus 2. You'll be having 4 plus x to the power of 2 by 5 minus x to the power minus 2 by 5 minus 2. Correct. Now it is correct. I just wrote the half before. Correct. So you will be getting this as half will come out. You'll have an integral ranging from 1 to 32. So you'll be getting x to the power 2 by 5 plus x to the power minus 2 by 5 minus plus 2 dx. So thank you for the error, showing the error in the calculation. So what happens is now you see x to the power 1 by 5 plus x to the power minus 1 by 5 squared is equal to x to the power 2 by 5 plus x to the power minus 2 by 5 plus 2. You agree? So you
Yes,
can,
sir.
yeah. So just see the calculation. Sometimes there can be some error. So you will get x to the power 1 by 5 plus x to the power minus 1 by 5 and have the integral from 1 to 32. So you may have forgotten to write 1 plus. That's the reason you got this. So half times this. So the integral turns out to be x to the power 6 by 5, 5 by 6 plus, and this is a modulo will be there, but since it is always positive, we don't need to take the modulo, right? So you'll have a square root of a number. X square is mod of x, remember that. So but here the mod is not required because x is always greater than 0. Your f of x is greater than 0. This is f of x, this is greater than 0. And you will have minus or plus 4 by 5 x to the power 4 by 5, right? And you just put the value of 1 and 32 here, you'll get the answer. So what will you get? You'll get, again I think we have done some 5 by 6, and this is 4 by 5, 5 by 4. Now this is correct, 4 by 5, 5 by 4. So I can take 5 out, 5 by 2, and you will be left with x to the power, what is x to the 32 to the power of 1 by 5, that is 2, right? So you are 32 to the power 1 by 5, 2 to the power 5 is 32. So you'll be left with this becomes 2 to the power 6 by 6 plus this becomes your 2 to the power 4 by 4, and you'll be left with a negative minus of 1 by 6, 1 by 4. Since it's from 1 to 32, 1 to the power anything is 1, so it's okay. This turns out to be 2 to the power 6 plus 2 to the power 4 minus, so we'll leave it at this 5 by 2, 2 to the power 6 minus 1 by 6 plus 2 to the power 4 minus 1 by 4. Is this okay?
Yes, sir.
Great. So we have seen how to calculate this one, so we'll just put the limits and we'll be getting this is okay. Next is using, this is a more sort of a conceptual thing. So what happens is, your x is equal to cos t, you have been given, y is given as sin t. So how will you calculate a line integral or surface or length of a curve using this? So this is your parametric equation, right? We discussed it in derivatives, right? Remember? So we need to calculate the parametric. So find the length of the curve with a parametric equation. So what will we do? Your length of the curve is given by 1 plus dy dx square times dx, right? Or you can interchange it as writing as dx square plus dy square and so on, right? So what do you think we should do here? And it is ranging between some a to b. There are ways you can solve it. You can also have a closed form solution. So for example, x is equal to say f of t. We'll not do this. Let's do a general case, but we'll do it in general, like the one if you even forget the formula that I'm going to derive. So what do you see dy dx as? Dy dx is, your dx is f dash t dt, right? And your dy is f dash or g dash t dt, right? And your so you'll be left with your line integral, your dx. This turns out to be a to b root over of 1 plus g prime t plus f prime t squared into f prime t dt. Agreed? Or simply f dash t plus g dash t dt, right? Is this right? So let's see.
Yes, sir.
What we'll do is, this we'll do it in two ways. So dx, so your dx is minus sin t dt, right? And your dy is cos t dt. So your dy dx is equal to cot, so it's just a second, so your y is, yeah, so y is cos x, cos t, and x is sin t. So we'll just replace, x is your cos t dt minus sin t dt. So you'll be having minus tan t dt. So your line is 1 plus tan square t 0 to pi by 6 or whatever we have here, pi by 3, 30 degrees or 60 degrees dt. So what is the integral of what is this? It's nothing but sec square t. You will take the square root, you will get sec t, or the mod of sec t, 0 to pi by 3 dt, right? And your tans are all positive in this range. So what is the integral of sec t? We have already seen this before. So that is log of sec t plus tan t. So we'll be using it directly here. log of sec t plus tan t. I think we, just a second, your dx is cos t, right? For example, cos t dt, sorry. So this will cancel and you'll be left with pi by 3, right? We have, remember that we are using this parametric equation, so we need to replace dx, right? Are you with me? Can you hear me?
Yes, sir.
So dx is cos t dt that we have found here. So dx is cos t dt, so I've just replaced the cos t and dt over here, and I've replaced the integral from 0 to pi by 3. So you see you get sec t over here. Nicely this comes out to be sec t, and you have a cos t, it cancels to 1, you get pi by 3. Let's see this equation that we derived. Does this hold? 0 to pi by 3, what is the square of these two? D prime x or f prime x, that is cos square t plus sine square t, agreed? And you have d root over dt, which is again 1 dt integral from 0 to pi by 3, which is nothing but pi by 3. You agreed?
Yes, sir.
So you don't need to remember this, but you can just remember this and use the parametric derivatives that we have been doing all along. So these are the two line integrals that we did. Next, what we'll do is we'll do some surface level integrals. So what are these things that we have been doing so far? So based on lines, we'll be extending these to surfaces. So what are surfaces in general? So we have seen volumes being generated like this, right? So you had a curve like this and you rotated about the x-axis, for example, and you got a surface like this, or a volume or a solid like this, and we already found the volume of this solid, right? Volume we found. Now can you tell me a way to find the surface area of the solid? So we used the disk method to find this volume, but how do you think we can solve for this is also known as a surface integral, right? So we're trying to solve the surface integral over the surface S. So the area of the surface will be the integral over ds over the surface of the solid S, right? So you see, instead of taking, so if you are rotating, this is symmetric, just in this case, if this is also fx, this is also fx, you see you have a circle like this with f of x as the radius, right? Now if I move a bit outwards as some ds, right, just like we showed previously for the volumes using cylindrical methods, what would be the area of this strip? If you open this strip, it's something like this, right? What would be one side? One side is ds, the other side is, what is this side?
Two pi f of x.
Correct. Yeah. So it is 2 pi f of x. Also, what is the other way we can calculate it that we showed in the beginning of the class? ds is 2 pi f of x into ds, right? Let's not write ds, maybe dA. That's right, over the surface S. That will be making more sense, right? Is this correct? So now,
Yes, sir.
now tell me, this ds, the other way would be using pi r1 square minus r2 square, right? And you will be again leaving out d of x square, right? This is your x sum d plus f of x and so on. So to prevent dx and d of f of x, so your curve can be slanted in any direction, right? So if you take a dx always in this direction, you're going to miss out on the length. Do you agree? For example, your curve is in this direction, so your surface area would increase dramatically if you just made d of x. If you made only d of x, you would only have a cylinder, right? You would not consider this slant, right? So your surface is increasing in this direction of d of s. So this is your length of the surface. So if you draw this circle, this circle will have a tangent at ds, and that tangent is what you should follow, as we have always been following in calculus, to make your next area. You agree, right? So if what is d of s? That is nothing but root over of dx square plus dy square. So again, it is sort of a line integral, but you're weighting it with the value of the function 1 plus f dash x dx. Is this okay? Can we go to the questions now? If you have a doubt regarding why are we taking ds, you can ask. I hope it is okay, right? Your ds, whichever strip you have, is along the tangent, because your circle, if you move along x, you're going to miss out this extra surface area, right? You can also show it more rigorously theoretically, but that is not in the scope. But will be, is the geometry clear? Okay. So here what we have is, our question says try to find the surface area for this parametric equation. Let's try to find it. So question number 5. So we have seen your surface area when your t has been given. This has been rotated, so this information must be present, rotated about x-axis. So if you are rotating it about x-axis, what will you do? So you see, we have the area given as 2 pi f of x 1 plus f dash x dx, right? So am I audible? I'm not able to hear a response for a long time.
Yes.
If you do you think okay, so yeah, so I hope there is no doubt till this point, right? Great. So we will be having this area. So I'm trying to parameterize f of x as well as parameterize the f derivative of the function of f. So what will you have? So what is f of x if we change this? So this is for values of t equal to 1 to root 5. So for example, f of x is given by, our convention is y, right? F of x is y for a 2D, for a dependent image. or a dependent figure. You agree, right? This is, we define y is f of x by the very definition of a curve in 2D. Next, what we need to do, we need to find dy dx. So in this case, instead of writing df dash x, dy dx square, or in this case let us write y, right, that is equal to f of x. This is equal to f dash x. So now let's see. So what is y dy? Your dy is 2 dt, dx is t dt, right? I'm taking the derivative of this, so you get 2t dt by 2, you get t dt. So it is dy dx, this is 2 by t, right? So what does the integral turn out to be? What is dx? We have already seen is t dt. So I'm just replacing all the components of the integral in terms of t. You'll get 1 to root 5, 2 pi. What is y? Y is given by 2t. This is your 2t, this is your y. Then you have 1 plus 2 by t whole squared, and you also have, this is your, you can easily understand, this is your this term, this is your y, and dx will be replaced as t dt. So next question I won't be doing, you will be telling me what would be the answer, because you are not interacting very much in this question. So you will be seeing that you'll be left with 2 pi 2t, and this is 1 plus 4 or t square by 4 by t into t dt. T is greater than 0 always, and so we can simply ignore the modulus that will be here and cancel these. So we'll be having 4 pi integral of t root over of t square by 4. So tell me how to integrate this one. What will I do?
Sir, we will take t square plus 4 is equal to u square.
Okay, so you're saying you will take t square, make it t square plus 4 of d, right?
Yes.
So if you make that, you will get 2t dt, and I have removed 1 2 from outside. Very nice. T square by 4, 3 by 2 into 4 pi by 3, right? From 1 to root 5, which is 9, 3 by 2, 4 pi by 3 minus root 5 to the power 3 by 2. Oh, not root 5, 5 to the power 3 by 2. Agreed? I hope the calculation is right, okay? So you'll have 27 minus root 5, or you have 125 square root. Is this okay? Something around?
Yes, sir.
Great. So the next question, as I said, will be prompted by one of you, so that I'll just do the integral. Let's see if you have understood the concept that we discussed. Number 6. What is the surface area of the curve given by the line xy equal to 1 between 1 and 2, rotated about the y-axis, or the x-axis, sorry. This is your, let's draw. So till now it's very simple question. So this is what the equation that I was referring to, right? That you cannot, your integral will explode at x is equal to 0. So we are considering only x is equal to 1 to 2. So this is your x or y is equal to 1 by x. It's a right angle hyperbole. You agree? Rectangular hyperbola. So it's 1,
Yes, sir.
1, 1, and this is 1 comma half or 2 comma half, right? And you're rotating this about the x-axis, so you'll be getting something like this. This is your volume that you'll be getting, and you want to find the surface area, right? This surface area is what you need to find. Something like a right-sided volcano. You can visualize this, right? Yes. So now tell me, what should be the area? So let's take this thing. So what is the area going to be? So you have y is equal to 1 by x. So what steps do I need to follow? What is the surface area of what is the infinitesimal area that you'll be having as a function of x? You can go ahead and answer.
Sir, 2 pi f of x.
Yeah.
Under root 1 plus dy by dx whole square.
Okay, dy dx. I'm just, this is just the formula, right? Into dx. This is your infinitesimal.
Dx.
Yeah, we've derived this just now. So what is f of x here? This is y. Yeah.
Y.
Y is f of x. So y, what is y? We are trying to find the integral in terms of x or y. You can tell me, like, so you're rotating about. See, you have limits of x given between x is between 1 and 2, right? So which one should you use as the variable for integration? Y, x or y?
X only.
X only. So you will replace y as f of x
1
as
by x.
correct. And what is dy dx?
Minus 1 by x square.
Very good. What is the square? Then the square root turning out to be 1 by 1 plus x to the power 4.
Minus. Yes.
And you'll have dx.
Into dx.
And this is your area from 1 to 2. Right?
Sir, y is between 1 to 2, no? So x will be 1 by 2 to 1.
Oh yeah. I just saw that. Correct. 1 to 1 by 2 to 1. I thought that y is between 1 to 2. So let's just write. You should have told. Yeah. So 1 and 1, and x is between. So I have taken this as a. So this is half and 1, half and 2, right? And this will be taking us 1 comma 1, right? Agreed? So I thought that this is x is between 1 and half. Sorry. So you will have x at half is y is equal to 2, right? X at 1 is y equal to 1, right? Thank you. So the integral is between half and 1, and so what is the solution that you need to do? You see, you have 1 by x cube root over of x to the power 4 plus 1. Now this is an integral, interesting integral to do. There is nothing very difficult in the question, but the integral is interesting. So you'll have 2 pi outside and we'll be left with x cube plus 1 by x to the power 3 to 1 dx. So let's just solve the integral. So I'll just copy this and I'll just write the answer later. This is equal to 2 pi I. Yeah, any idea how to solve this?
Sir, using by parts.
Yeah. So why do you think you will be using by parts here?
Sir, we can integrate x raised to 4 plus 1 under root 10, differentiate x cube.
You can integrate x to the power 4 plus 1. Are you sure? I don't think you can integrate. See, you have x to the power 4, right? Plus 1. There is no closed formula for this. Right? But you see, if we can make this function of x to the power 4 in some way, right? And you have an x to the power 3 also, right? In some form. But it's in the denominator. You agree?
Yes, sir.
So by parts is right, but which one will I integrate and which one will I differentiate is the question. So this is sort of an easier question than it seems. So this is very easy, right? So this one you can just differentiate because you can't integrate this one, and this one you will differentiate, right? Like just the first day you had told me that you cannot, whatever you can't integrate, you will be differentiating, right? You remember, right? You only had told me. So you cannot integrate this, you will differentiate this. So let's integrate this. So you'll have minus x to the power minus 2 root over of x to the power 4 plus 1. Is this okay? This is the first term. Minus x to the power minus 2 or by 2, right? This turns out to be plus into x to the power 4 plus 1 into 2. This is integrated. I'm just writing it down, and because I'm here, I can't hear your voices, so I'm just going to write this. Right? And ddx of x to the power 4 plus 1 is 1 by 2 x to the power 4 plus 1 into 4x cube, right?
Yes, sir.
4x cube dx. This I have by parts. In the middle one is negative, so negative I made positive. Good. So you'll have a half outside x to the power minus 2 x to the power 4 plus 1, and this integral you see now becomes a simpler equation to solve. It becomes x by x. Now you should tell me how to solve this. If you can't speak, you can type it, Mr. Pandey, but I think you should tell me what is the process that will be used to integrate this. This is very simple. Okay, x square is equal to y. I think substitution makes this question, yeah. So x square equal to y will give you a good substitution. That's very good. Or you see you have a numerator. I'll make this d of x square plus 1 or just x square for our case, and divide by half, right? Is this okay? As same as substituting. Do we know this integral? We have a closed form for this, right? Log of x square plus, so last day we had used, this is the closed form. We have also seen this. You can just take the derivative and see the proof of this. Very simple. Or you can replace x as a sec theta or a tan theta and see, right? Right, x is equal to a tan theta will solve this. If you try to do this as a homework, so what you will be left with? You'll be left with sec theta. You'll be left with a times sec theta. You'll get a cos theta. You integrate a sin theta, and you'll be getting terms that you would easily integrate, right? These are substitutions that you should be using you should be able to do very simply now. So this is half x to the power minus 2, and you have a negative sign, x to the power 4 plus 1 plus log of x squared plus x to the power 4 plus 1. Please practice a lot of indefinite integrals. 100 of them if you solve in a particular day, I think you will be able to get it. You need to solve more and more questions for indefinite. It's not trivial. You need to just practice. It's an art. It's not intelligence that needs to be done in integration. Integration just needs half of the things must be remembered, and half of the things you must be able to substitute intelligently, or use your methods or tools that you have because it's not a forward process, it's a reverse indeterministic process. So now you can replace, this is between half and 1. Can do the calculations and see, because you need a calculator to do this. I'm not going to do this now, so just replace the integral, and we have got the integral. Just put the limits, use fundamental law of calculus and just replace it. Next, find the line integral of the length of the curve. So we'll do a couple of easy questions, and then will be some of the questions that Mr. Pandey had sent. We'll be solving those as well. We have used GeoGebra, but today we'll not be using it because of the lack of time. We have already done a few difficult questions. So let's solve this theoretically only. So we need to find the line integral of the curve between 1 and 4 for y is equal to x to the power 3 by 2. So how will this look? Will it have a negative part? What is the domain of the function? What is domain of f? Just try to revise as your exam is near. Yes, it's 0 to infinity, because the square root is not defined for any values less than 0. So okay, let's do it. So we'll do this, just checking if it's recording. Correct. So it looks something like this. Since it's the square root, it's more than 1, sorry, so it's this. Correct. Next, what we'll do, we are told to find the line integral, right? So how will we find? So we'll do something like this, dy dx. So we remember we need to do this, right? So they do this, root over of 1 plus dy dx whole square dx. So what is dy dx? It's 3 by 2 times x to the power of 1 by 2. You square this, you get 9 by 4 x, which is integral of 1 to 4, integral of 1 by 9 by 4 x. Let's put this 1 to 9 by 4 dx and 4 by 9. Is this okay?
Sir, y is given between 1 to 4, no? We have to...
sorry again. See, good. So what is the values of x? Y is equal to 1, x is equal to 1.
1.
Y is equal to, I'm not seeing again, I'm just putting y, sorry. Y equal to 4. 4 is equal to x to the power 3 by 2, take square on both sides. So you'll be left with
16 raised to 1 by 3.
As x, right? This is correct. So you will be left with 1 to 16 to the power, or this is nothing but 4 cube root of 4. Right, so this is 4 squared 4 to the power 2 by 3. Good. So you have 4 by 9, 1 plus 9 by 4 to the power of 3 by 2 into 2 by 3, right? This is okay? So we're having 8 by 27 1 plus 9 by 4 to the power 3 by 2, which is 1 plus 9 by 4 to the power 2 by 3 by 2 minus, if you put 1, 13 by 4. Is this okay? I remove this. I have very good. Okay, any doubts?
No, sir.
Okay, so last two questions. So this question was sent from this book that you are told to follow. These two questions. These questions will generate integrals that are not closed form. You need to do these integrations numerically using some trapezoidal Simpson's rule. You can just use a computer to solve the integral, but we'll be just getting the integrals for you. We're getting the functions. You can put it into the computer and see what the value of the surface area is. So these two, let's quickly form the integrals, and you'll tell me the first one, and second one I will do, because the second one is easy. First one will be telling it's a revision of some derivative concepts. So number 8. So you're saying y is between minus this. So we had shown that area, if we integrated, was 2 pi f of x ds of x. Agreed? We can also write this as 2 pi f of y ds of y. In the same way, if y is, we make x the independent dependent variable. In this case, 2 pi y 1 plus dx dy squared into dy, right?
Yes, sir.
So all I did is I just substitute x and y. I have just interchanged them, and I can do that, right? X and y do not, like, it's just if we see that there are one-to-one functions and inverse exists, so you can do either of them. Agreed? Or you'll have to make an inverse accordingly. Let's do the number 8. So what would be the steps that you will be needing to do? What are the terms that you need for number 8? So tell me, how will you form the integral? What is f of y? In our case, or x, f of y is x, which is given to us 0 to y integral of tan y. Was it tan t dt? Right? Yes or no?
Yes, sir.
So what is it? Log of sec t
Sec t.
from 0 to y, which is nothing but log of sec y. Agreed?
Sec 1. Yes, sir.
So this is your x. What is your dx dy?
Sir, we will find using Leibniz rule.
Yeah, Newton-Leibniz. We have proved that Newton-Leibniz using fundamental theorem of calculus. So just put y. So tan
of
y
y
into ddy of y minus 0. Minus 0 dy dx or something like that. Tan 0. This is 0, which is equal to tan y, right? Very good. Next. So such a nice integral you are getting. So dx dy squared plus 1, what is it? Which is nothing but equal to 1 plus tan square y whole root over, which is sec y, right? So your integral will turn out to be 0 to pi by 3 log of mod of sec y. Sec y is positive between 0 and pi by 3, right? Into sec y. Right? Is this integrable? Let me just check once. Just once I'll check. Sec y. The derivative of this is sec y into sec y tan y. So it's told to just let's leave it to this thing, and then we'll see if it give time permits. Since the question says we need to just form the integral, this is enough. So we can just feed it to a computer and see if it is going to, since it's a definite integral, we can use numerical methods to compute them. So do you think it can be solved? So if I take z is equal to log of sec y, we'll say sure, why can't it be like easily solved? Dx dz dy is your sec y tan y, so you get tan y. Integration by parts you can't solve, I think, because sec y and tan y, which one will you integrate and differentiate? So this is, yeah, you can use Desmos, but you can easily use the integral in Desmos. So this is 1 minus sec square y. Oh, nice. And you have sec y outside. So you can't directly do it, I think. So you'll have e to the power z as sec y. So it's not integrable. So you see, you have tan y, right? So the derivative of this function is tan y, which is nothing but, so you see sec y here is e to the power of z, right? So you'll be replacing this integral as e to the power z root over of 1 minus e to the power z, which is not integrable. It's non-integrable form, right? Log of sec y is, log of sec y, just a second. What is log of sec y? It is z. What is sec y? That is e to the power z. And you have tan y, which is sec square y minus 1 root over. Yeah, I know. So I'm just showing why it is not integrable. It's written you cannot integrate, just I'm showing. So it's e to the power 2z minus 1. So the integral will turn out to be e to the power 2z minus 1 into e to the power z into z. This is not an integrable form. So you can't integrate this. That's why the question has been given to solve using a numerical calculator. But we have seen a very nice closed form, sec y log sec y. That's the thing. Once you learn a bit of numerical calculus, you will be able to do it using Simpson's or trapezoidal rule, which is nothing but our Riemann integrals that we have done. You will take h as small. I can give you an assignment. What you will do is try to code this yourself. If you know how to code, try to find the code for this yourself. How will you do that? So a function is given to you. You can have small h values, right? And you can have a for loop which will calculate this area, right? We have seen in Riemann integrals. So it will do h times f of x naught plus kh. A plus equal to a you set as 0 for I equal to x1 to xn, right? Try to code this algorithm yourself. You will get a feel. This is known as a trapezoidal rule. Just we are taking a detour to tell you. I hope you can write the code for yourself instead of using a predefined software. It will give you some confidence of using numerical methods. So all definite integrals can be solved with a computer using this method. You can use, there are more fine methods, fine-grained methods. It's only a which has better approximations like the Simpson's rule and so on. Anyways, so next one is a equation which says x to the power half plus y to the power half is equal to 3. Sort of an inverse quadratic. So it looks something like this. Y is 3 minus root x squared. Right? It's rotated about the x-axis and you're told to find the surface. So you have at x is equal to 4, x is equal to 1, y is equal to 4. So how does this curve look? At x is equal to 0, y is 9, right? So I'll just show you how to plot that anyways. So this, and at 4, x is equal to 4, you have y equal to 1. This is your square root of y. This is minus of square root of y. And you have 3 minus square root of y. So this is shifted upwards and you have a square of that. So hopefully you can take the derivative and see if it is a concave up or a concave down function. We'll see that, but that's not important. If time permits, we'll see that. Anyways, so what should be the integral? What is dy dx? What is the surface area? Surface area we can form in terms of 1 plus dy dx squared dx 2 pi f of x, right? And x is between 1 and 4, right? This is your area. Now prompt the f of x. What is f of x? Can you help me with f of x?
F of x is y.
Correct. So that is 3 minus
Root x square.
And what is dy dx?
3 minus root x.
Okay, 2
minus 1 by
root x 1 by
1 by 2 root x minus 1 by 2 root x.
Correct. Is a negative. Differentiated the outer function, then you differentiated this. So you have half minus, yeah, correct. So you are left with 3 by root x minus 1, or 1 minus 3 by root x. So this is 1 plus 1 minus 3 by root x squared dx. Again, this forms the integral. We'll see how the curve looks after solving the last question, because that will be a revision if it is a concave up or concave down function. And then we can use Desmos and validate for the last time before we end the course. I don't know whether I will give a concluding session next week, but if we are not going to give, this is the last question of the tutorial set of 12 sessions that we have taken. I hope you found it interesting. So anyways, so you have y, right? So x is equal to y plus 2 root y. Can you tell me what to do to solve this? Find the length of the curve. So what should I do? Should I take x as a function of y or y as a function of x? Which one should I follow? Should I do
x is a function of y?
This is also equal to integral of 1 plus dx dy.
Dx by dy.
Correct.
Dy.
So let's do dx dy. You get 1 plus 1 by root y. That's it. Half and 2 will cancel. Very good. Next, dx dy squared, again a bit of calculation but it's worth it. This is equal to 1 plus 1 by y plus 2 by y plus 1. Agreed? Which is equal to 2 plus 1 by y plus 2 by root y. You can take root y common. What will you get? 2 to the power half plus 2 to the power minus half plus 2 square root and you will have y to the power of I'm multiplying, just a second, what we are doing is multiplying this, so just a second. This is this equation. Y to the power minus half, y to the power minus 1 plus 2. So what will I do? I will take y to the power minus 1 outside. So you'll have y to the power minus half. Let's wait just a second. So 2 times y to the power minus 1. So what are we trying to do is we are trying to make this equation a squared. So you see y to the power half squared is equal to y to the power minus 1. You agree? Right? Yes or no? Okay. So if we can make a perfect square inside, so the integral now has turned out to be y between 1 and 2, you have the square root of 2 plus y to the power minus half plus 2y to the power minus. This is your integral. So this is what do you substitute to get a proper equation. So do you have any idea what to do? I think there is a very nice substitution that you can do. That just came to my mind. Okay. So if you can, the idea is to make perfect squares and form an equation something like this, a square plus x square. This is the idea, because that's the form you are seeing. You are having a minus 1 and you are also having a x to the power minus 2 in our case. So let's take y to the power minus half as minus 1 as common. So you see what you will get. Why am I doing this? It will be very clear now. So you get y to the power minus 1. You have y plus 1, 2y, right? 2y plus 1 plus y to the power half. Do you agree? Am I audible?
Yes, sir.
So are you understanding what I'm trying to do here? See, there's a 2
Yes,
here.
sir.
What you're trying to do is you're trying to get a perfect square so that you can substitute. So you do this, you get minus half outside, right? And in the internal, inside the square root, what do you have? You have 2y plus 2y to the power half plus, what do you have? You have 1, which is nothing but 1 to 2 y to the power minus half. Now can you tell me what to do if to make this a perfect square? This is y to the power half plus 1 squared. If I do this and multiply by 2, what will I get? Will I get what I need? I'll get 2y. Alright, I'll get, I think there will be a half somewhere here. Yes, if I do this, I'm trying to make a perfect square out of it, right? So I'm taking y common, 2 common here, so y to the power half plus 2 minus 2. That's all I'm doing, right? So what do you have? So you have y plus y to the power half plus 1 by 4 minus 1 by 4. This is what? This is y plus half to the power of agreed? Yes or no?
Yes, sir.
So this is y plus, so you are left with minus half plus 1. So just this I have written as this, minus half. So I left with, that's what I wrote, minus half plus 1. Is my calculations, I hope my calculations are correct. So now what will you substitute? I hope now you are understanding why I did this. This itself is a good integral question. Right? 1 to 2. So you take y to the power half plus half as t, as you like it in this one. And again you didn't tell me that this addition is plus half. So what are you left with? Y to the power minus half times half dy is equal to dt. The integral converges, right? Means I think the integral has a closed form, right? So you have 2 times, so I move this side, 2 times dt, you have dt, and this integral becomes t squared plus 1 by root 2 squared. And what will be the limits? For 1, this is 3 by 2. Let's put it, y is equal to 1, t is equal to 1 plus half, that is equal to 3 by 2, and y is equal to 2. You have 2 to the power half, or square root of 2 plus 1 by 2. So half plus square root of 2, from 3 by 2 to half of square root of 2. This is something around 1.8, from 1.5 to 1.8. So what is this? This is as a closed form solution, a square plus x square. We had seen this. This is your closed form solution. So you have t into t square plus a square by 2 log of, this is your closed form solution. This is t into t square by root 2 square or half by 2 plus, then you have 2 outside, a square by 2 is 4 log of t plus t square plus 1 by 2. Is this okay?
Yes, sir.
So I think we have been able to do this, and then you can just substitute the values and get the integral equation. So let's, for the last question, can you tell me if this function is decreasing? We have already found, but is it a concave upwards or a concave downward function? Let's see. Y is equal to 3 minus square root of x squared, right? So what does this look like? What does 3 minus root x look like? root x is this, right? Just transformation of graphs. This is minus root x and this is, so it goes to at 9 to 0 and then 0, this is 3. This is your graph, 3 minus root x. Yes or no? I hope you were there in the first few sessions that we had. This is your graph of 3 minus root x. And if I square this, will it become a, what will it become? Will it become a concave up function or a concave down function, or what type of a function will it become? So you see, so if I expand this, you'll have 3, or you can I'm just trying to not take derivatives. So dy dx, if you take, we have already second derivative. Yeah, second derivative is for concavity, but without second derivative, can we try to can we say that whether the graph will be concave up or downwards? Decreasing function, all right. So you see, decreasing function, it will always happen, as we had seen. 3 minus root x half root x, right? This is a decreasing function. Right, so for x between 0 and 9, this is decreasing, right? So your function, and this is squared, so you will have a something like this. So, but does the concavity change for the graph? So for changing of concavity, we need to see the, so at 9 you will be changing your sign. So my question is your graph going to look like something like this or something like this? Which of the two will it look like? 1 or 2? What do you think? Yeah, second derivative test is easy in this case. So you see, so you have a 3 minus root x by 2 root x. You're saying it's easy in this case, you will be taking a derivative again. So negative is there, ddx. So see, just put ddx. So I'll just try to figure out anyways if I can, but let's do the mechanical way. 2 root x. I'm just I don't like calculations, that's the thing. This minus, so I took the derivative of the numerator, minus 3 minus root x into 4 times, let's take half outside, not required, half is not required only, 2 root x into x. So let's put value of 1 for example. If you put 1 here, so you'll be left with minus 1 minus 3 by 2. This is greater than 0. We have a negative outside, this is less than 0, so minus of this is greater than 0. So if it is greater than 0, which means it is a greater than 0 of the derivative, means there is a minima or it's a concave up at this point. Something like this is what the graph looks like. So let's see if we can just plot the graph using Desmos to just validate what we have done in the So y is equal to 3 minus root sqrt x. This is what we had drawn just now, and if you put a square over here, so you see just as we had discussed, right? And you can put an A and see, you add a slider and see how the curve changes. This is also a way to use this. So I hope with this we come to the end of today's session. I wish you all the best for the exams, but if we have a revision class next week, we'll be getting a mail, but I don't know what is the logistics yet. I hope you enjoyed the 12 sessions that we had, and hope to see you in some other course some other time. So keep an eye out if the people keep an eye out if they are going to give an extra class, scheduling an extra class after this session next week. Please attend it, or we'll be seeing you in some other session, and give the exams well. Thank you. So we'll be stopping recording, and bye.